Nuclear testing has not been exclusive to the United States. Several other nations have conducted extensive nuclear programs. The Soviet Union, now Russia, carried out nuclear tests primarily at the Semipalatinsk test site in Kazakhstan, and Novaya Zemlya in the Arctic, totaling around 715 tests from 1949 to 1990. France conducted nuclear tests, primarily in Algeria and later in French Polynesia, performing approximately 210 detonations between 1960 and 1996. The United Kingdom conducted its nuclear tests in Australia and the Pacific, totaling about 45 detonations between 1952 and 1991. China began its nuclear testing program in 1964, conducting around 45 tests at the Lopnor site in Xinjiang province until 1996. Global consequences of nuclear fallout from these tests include widespread radioactive contamination, cross-border environmental damage, and international public health impacts. Shared global fallout containing radionuclides like cesium-137 and strontium-90 has been detected worldwide, underscoring the international nature of nuclear testing's environmental and health consequences. In response to the extensive nuclear testing history, international safety and disarmament efforts have intensified. Major initiatives include the Nuclear Non-Proliferation Treaty, NPT, signed in 1968, aiming to prevent the spread of nuclear weapons and technology. The Comprehensive Nuclear Test Ban Treaty, CTBT, although not yet in force, has significantly curtailed global nuclear testing activities, pushing nations toward disarmament and non-proliferation. Contemporary policies emphasize securing and reducing nuclear arsenals through bilateral treaties, such as the Strategic Arms Reduction Treaty, START, between Russia and the United States. Global institutions and forums including the International Atomic Energy Agency, IEA, and United Nations disarmament committees continually advocate for nuclear disarmament, safety standards, and transparency to mitigate nuclear risks. Despite their devastating potential, nuclear tests have led to significant technological and scientific breakthroughs. Advances include improved understanding of nuclear fission and fusion processes, radiation effects, and materials science under extreme conditions. These developments have influenced fields ranging from medical radiology to astrophysics. Peaceful nuclear explosions, PNEs, notably explored by the United States and the Soviet Union, aimed at civil applications such as large-scale excavation, resource extraction, and seismic research. Examples include Project Plowshare in the US and the Soviet Union's nuclear explosions for the national economy. While demonstrating potential benefits, PNEs were ultimately curtailed due to public health concerns, environmental consequences, and economic impracticality. Underground nuclear testing has had profound seismic and geological effects. These detonations frequently triggered induced seismicity, artificially generated earthquakes, which, while mostly localized, sometimes had noticeable impacts hundreds of kilometers away. Nuclear tests altered geological structures, creating subsurface cavities, fracturing rocks, and modifying local hydrology. Repeated nuclear detonations caused visible changes in landscapes, including ground subsidence, sinkholes, and altered terrain features. Such geological impacts necessitated extensive geological and environmental assessments and remediation efforts, illustrating the lasting legacy nuclear testing has on the Earth's geological integrity.